Welcome to Physical Sciences Consultorium. This video is part of the series How We Know the Universe. In this episode, we ask a question that sounds almost impossible. How do we know the age of stars when we were never there to watch them grow? Age feels different from distance or motion. You can see how far something is. You can see how fast it moves. But age belongs to the past. And in astronomy, the past cannot be replayed. So how can age be known at all? In everyday life, you often know how old something is without having seen it from the beginning. You judge age from wear, from structure, and from patterns of change. Age leaves traces. Age is not measured by memory. It is measured by change over time. When systems change in predictable ways, the current state contains clues about how long they have been evolving. This idea applies far beyond everyday objects. Stars are not frozen points of light. They change slowly, but they change in ways governed by physics. Their brightness, their color, and their internal structure all evolve over time. Crucially, stars do not change randomly. Given similar starting conditions, stars follow similar paths of change. Physics sets these paths. Stars cannot choose how they evolve. Astronomers organize stars according to their brightness and color. When this is done for many stars at once, clear patterns appear. These patterns reflect different stages in the life of stars. As stars age, they do not stay in one place within these patterns. They move along predictable tracks, slowly shifting their position as their physical state changes. This motion is not literal movement through space. It is movement through states of change. Individual stars can be ambiguous, but groups of stars tell a clearer story. Stars that form together start with the same age, but spread out along predictable paths as time passes. The overall pattern acts like a clock. By comparing observed patterns with patterns predicted by physics, astronomers can estimate how much time has passed. Age is not guessed, it is inferred from how far change has progressed. This method works because physics tightly controls how stars change. Different ages produce different patterns. Those patterns cannot be freely imitated. This severely limits what the age can be. Stellar ages are not exact numbers. They come with ranges and uncertainty. But uncertainty does not mean ignorance. It means honesty about limits. Astronomers do not know the age of stars by watching them age. They know it by recognizing how physical systems change over time in disciplined, predictable ways. Change becomes the record of time. If this way of understanding space science is useful to you, this is exactly what Physical Sciences Consultorium exists for. We focus on how scientific knowledge is built. If you found this episode helpful, please like, share, and subscribe to the PSC channel.